All right, this is a challenge problem and real-world connection problem in our unit on quadratic functions, specifically about graphing quadratic functions in vertex form. And this refers to an absolutely true scenario, one of the greatest college football plays of all time, happened in 1994. It's referred to as the Miracle in Michigan, and it happened at the University of Michigan. The University of Colorado was playing the Wolverines, and there were 6 seconds left in the game, and CU, Colorado, was down by, I think, 5 points. I'm not quite sure. And they only had time for one play to go, and they had about 75 yards to go to get a touchdown. Okay, so Cordell Stewart, the quarterback for CU, who went on to have a great professional career at Pittsburgh, he throws the football down the field, needing to score a touchdown. And I looked at the YouTube video a few times to try to get a sense of what the numbers were, so I have to make some guesses here. But let's say the release point from when he let go of the football was 6 feet off the ground at his own 26-yard line. And then the ball was tipped at the opposite end of the field at the 1-yard line. And then it was ultimately caught by Michael Westbrook, who you can see in this photo, for a Colorado touchdown. And let's assume the ball reached a maximum height of 60 feet above the field when it was sort of halfway down the field. And we want to determine a quadratic function that models the path of the ball. Okay, so let's draw a quick picture first. And if you don't know how a football field is set up, that's going to be important here. So we'll try to model that a little bit as well. So let's say this is the 50-yard line halfway down. 2, 3, 4, 5. 1, 2, 3, 4, 5. And so this is called the goal line, right there. And this is Cordell Stewart was roughly right here, and he roughly let go of the ball at the 26-yard line. The ball was about 6 feet off the ground, and he threw a touchdown, and that's where Michael Westbrook caught it, right there. Okay, let's assume it was tipped at the 1-yard line, so that's right about here, and let's assume it was 6 feet off the ground at that point as well. So we have to make a couple assumptions. So that is, whoops, let me not erase all those. And so that is the point 1 comma, let's call that 99, okay, because the football field is 100 yards long, so that's 1 comma 99 right there. Okay, and so we know right about here the ball was about 60 feet in the air. Okay, so a couple things we need to worry about. First of all, we need to worry about units. Football fields are measured in yards, and I just told you the ball was 60 feet in the air. So let's change that 60 feet into yards. So let's say it was 20 yards in the air, 3 feet in a yard. We need to figure out exactly what the x-coordinate is for that vertex, okay? And it's going to be exactly halfway between the 26-yard line and the 99-yard line, okay? So let's find the average of those two values. So 26 plus 99 divided by 2 is 62.5. So that means that the ball had traveled 62.5 yards horizontally. No, excuse me, had traveled to the 62.5 yard mark, and it was 20 yards above the field. By the way, in football, you wouldn't see the 62.5 yard mark. That would actually be the opponent's 37.5 yard line. Okay, but we are assuming that our scale goes from 0 to 100 here. All right, so I think we have the information we know, and to be clear, that information is we have a very solid point and we have a vertex. Okay, so let's go ahead and plug that information into vertex form. Remember, vertex form is y equals a times x minus h squared plus k. And we have our h and k, and we don't know what a is, but we'll try to figure that out. So y is a times x minus 62.5 squared plus, oh, I messed that up. I made a quick mistake there. Nope, I did that right, my bad. And plus our k value of 20, okay? So just you can see it's, I'm a little confused here right now. This is our h value and that's our k value, okay? The coordinates of my vertex. All right, so now we don't know what a is, but we need to figure that out. And so we can take any other point on our parabola, and we have two other clear points, the 26.6 and the 199. We can plug those coordinates in for x and y. So we're going to take the 26.6 point, and y is 6 feet above the ground. A, we still don't know what it is. X is 26. And now we just need to solve for a, okay? So let's do some simplifying. 26 minus 62.5. And then squared. So a times 1332.25. And then plus 20. So now our goal is to solve for a. Okay, subtract 20 from both sides. We have a negative 14 equals 1332.25a, and then we can divide both sides by that 1332.25. And so we get a is negative 0.0105, okay? And so that's a tiny decimal, meaning it's a pretty wide parabola. So in terms of, as far as parabolas go, it's a pretty wide, flat, roughly flat parabola. So that's our a value. So now we can just take the information we know and write out our vertex form. Y equals negative 0.0105 times x minus the coordinates of our vertex, the h piece, plus 20. All right, and that would be the vertex form equation of that incredible football throw that Cordell Stewart made back in 1994. All right, that's a good place to stop.